Hello, everybody. This is Mr. Folly, and welcome back to, still not writing, Mr. Folly, and welcome to 3.3. So let's take a look at them. So this is talking about radioactive decay. Make sure you have a periodic table out because we need to be able to find these numbers, and make sure you have your calculator out so you don't make cheesy subtraction mistakes. So there are three types of radioactive decay: alpha, beta, and gamma. And we're going to look at each one individually. So, alpha. An alpha particle is really a helium nucleus. So it's 4/2 He plus 2. Now, I'm going to be honest with you, no one ever shows the plus 2 on this. An alpha particle, no one shows it, but it is the truth, okay? This is the most massive of the particles. Its mass is 4. It has a positive charge, so it's attracted to negatives and repelled by positives. It's easily blocked by skin or paper. Excuse me. The type of decay for all elements with a mass over 82. Remember how we said all elements are radioactive if they're over 82? They're going to do alpha decay. Alpha decay produces an alpha particle, and that means it's going to be a product, so this would be my alpha particle. Notice it's on the right-hand side of the arrow, and the mass and protons decrease. 226 decreased to 222. That would be the mass decreasing. The number of protons, 88, decreased to 86. Okay? So the masses on the top left, which are the top left. So what we can look at here is 226 equals 4 plus 222. Okay? So that will always be true. 88 equals 2 plus 86. Okay? So those will always add up to be the same. And every type of decay everywhere. Beta decay. Look at that fancy B-looking beta. It's really where a neutron turns into a proton and electron and shoots out the electron. It looks like this. It also looks like this, 0, -1, B. So that also looks like is this guy over here. Okay, these are the same, right? The mass is negligible, and we talked about that today in class. It has a negative charge, so negatives are attracted to positives and repelled by negatives. It's blocked by a sheet of metal or wood or stronger things. So remember how alpha was blocked by paper? This one would go through paper. This one goes through your skin. Okay. This type of decay occurs when it has too many protons, when it is below the band of stability. So let me show you this right here. This is the band of stability, okay? And if you have too many protons, this will say atomic number, which is the number of protons. So if I have too many protons, like I'm over here, I want to be stable. So this is like a stable neighborhood. So my goal in life is to live in a stable neighborhood. I live in Indiana, so let's say that's not stable. So my pumpkin patch in Indiana is in a world of craziness, okay? All the farmers going by and everything, and their tractors and John Deere. I want to be stable by either going up here, but that's not what I do. I go to the left and I just lose protons. So this means I have to turn into something else. So if I want to be in a more stable place, I can't be a pumpkin farmer. I have to go become a more reasonable lifestyle like a teacher. So notice right here, this is the band of stability. If you're on, you'll be given this. If you're on the band of stability, you're stable. These are unstable. And this is where it does beta decay. And there's a line right here. This does alpha decay if it's anything over here. So, here we go. Get ready for some amazing color things. This is unstable and does alpha. Beta is unstable down here. And in this case, you could see that it could be both of them. All right. So let's hop back up to this. We talked about the band of stability, a touch there. Below the band of stability, beta decay produces a beta particle, which I showed you how to write that, and nitrogen-15 undergoes beta decay. Nitrogen-15, 15 means that. I got the 7 from the periodic table. Beta decay is 0, -1 See, 15 equals 0 plus 15. 7 equals -1 plus what? 8 minus 1 equals 7. There you go. And again, that same adding thing works. Gamma decay is really just energy. So it has no mass. That's true. It's not negligible mass. It's no mass. Mass is 0, 0 protons, and I tend to write it like that for gamma. This is how Word writes it, but you get it. All right. It has no charge. Energy has no charge. And it can only be blocked by several feet of lead or concrete. And this occurs with other types of radioactive decay. It does not impact your protons nor your neutrons, but partner decay does change protons and neutrons. Gamma decay produces a gamma particle, which means it's going to be on the right. Example, in the alpha of uranium-238, 2 gamma rays of different energies are emitted in addition to the alpha particle. Uranium-238, there's the mass. Periodic table tells me uranium is 92. Alpha decay, alpha particle, 4/2 alpha. And then gamma, 2 gamma particles. There's a 2. So 2 times 0, still 0. 2 times 0, still 0. So over here, 238 yields 4 plus something. Well, that's going to be 234. 92 equals 2 plus something. That's going to be 90. Okay. You can have more than one type of radiation as shown by the coefficient. So that 2 means I have 2 gammas. I could also have 2 alphas. Okay. Radiation can be blocked simply. If it is blocked by paper, it is also blocked by wood, and is also blocked by lead. Okay, so there you go. Band of stability, neutrons are like glue. Too much glue, it falls apart. Talked about this in class today. Not enough glue, it falls apart. The band of stability predicts if nuclei are stable or not. The x-axis is protons. The y-axis is neutrons. Dots on the graph are stable. Everything else is radioactive. If you're above the band of stability, it has too many neutrons. Beta converts a neutron into a proton and an electron. You know, I thought that was wrong when I saw it before. Above the band does beta decay. So I made a boo-boo. I thought I had that wrong. This is still alphas in here. There's another type of decay we don't do anymore. Below the band has too many neutrons. If a nucleus has over 82 protons, it is too large, so it does alpha decay. So I'm going to come up here and fix it. I guarantee you, your quiz question is going to be, what mistake did I make on my podcast? So let's see here. Where'd beta go? Beta decay produces a beta particle, and this is below the band of stability, so it's going to be above. Oh, where did it go? Above. So make sure you make that change, and make sure you have a great weekend. And to that, I will say, toodaloo.